Morning. So I teach an applied data analysis class to behavioral science students. And oops, are these forwarding on their own? Okay. And I've noticed that for many students, they're able to plug and chug formulas, but oftentimes don't understand p-values and sampling distributions. But with permutation tests, they literally shuffle the data, see the null world emerge, and ask, how unusual is my result? So I created an interactive webR tutorial that guides students step by step through the logic and implementation of permutation tests for null hypothesis significance testing. The activity uses data from Hoffman and colleagues, which is a study that's on the Open Science Framework. And the study aims to understand how different types of uncertainty visualizations can influence decision making. So study participants competed against Blorg in an ice boulder game, and they had the option to buy or rent a special boulder that might help them, might give them an advantage. But this special boulder might help or it might not. And in order to help them decide whether they should rent this special boulder or not, they were randomly assigned to view one of 4 different uncertainty visualizations. All of these uncertainty visualizations presented the mean sliding distance of the standard boulder and the special boulder, and the uncertainty around those averages. Today, I'm going to focus on the first and the third graphs here, which is a confidence interval graph and a rescaled confidence interval graph. Now, the rescaled confidence interval graph differs from the initial graph in that the y-axis is wider, and it makes the difference between the standard and the special boulder appear smaller. So the null hypothesis here is that there is no difference in average willingness to pay for this special boulder between the standard, or I'm sorry, between the conditions, confidence interval and rescaled confidence interval in this situation. So the webR activity begins by having students pick 2 conditions, and in these conditions, they compute the average willingness to pay for this special boulder between the 2 that they've picked. This orients students to the real data before any shuffling begins. Next, they randomly reassign the labels 5,000 times. And in this graph, the first panel shows the difference in the real data. The remaining panels show the difference in 3 different shuffled data sets. So in this way, this null world emerges step by step to students. So they shuffle the data, they compute the mean difference in each of the shuffled data sets, and these 5,000 differences between these means form this hands-on sampling distribution under the null. So the next step then is for them to calculate the proportion of those 5,000 differences that are as extreme or more extreme than the observed difference. And this forms the p-value, this hands-on version of the p-value. In this particular instance, 4.8% of the shuffled data sets produced an observed difference that was as larger than the observed data. The students also then used those 5,000 differences to compute the standard deviation, and that gives the standard error, the expectation for how much variability we would see based on the null distribution, if the null distribution were true. And then they take the observed group difference, divide it by the standard error. This gives them the standardized test statistic. That's overlaid onto this null distribution so that they can see just how unusual their result is. The activity finishes up by having them conduct a classic independent samples t-test so that they can take the results from the t-test and map them onto these parameter estimates that they obtained through the permutation test. So the beauty of running this in webR is that you can introduce it early in the process. Students don't have to install anything. They can just run it in the browser. This activity, the full activity, is on GitHub, along with all the materials that I used to create the activity. And I hope that you consider taking a look at them, using them, adapting them as you like. Thank you.